Hi everyone, welcome to the lab. Today in this new episode of Old But Good Tech, we are reviewing this great mystery box. As you can see, it says Digital Logic Probe on the front, DLP for short, and the name is DLP50, and it was made by Sansei Electronics Corporation in Japan. So, for those who don't know, digital logic probes are measuring devices that are used in digital electronics when there's some logic going on, and it just serves the purpose to measure signal changes, or digital signals. And this is a very important tool to have when you're into electronics or when you're an electrician, because it allows you to see what's happening on your circuits, on PCBs, for example. This particular one was given to me by my father a few years ago, and I've used it since then, and it's a really good device, old but good, as I say. As you can see, the box has seen better days. I'm not the first owner of this probe. It was belonging to an old man before me, and then he just sold it on the internet, and my father bought it and give it to me. So let's open this box. As you can see, first thing, there's a manual in the box. A pretty good manual, I must say, because it's pretty complete. It says Sansei Electronics here as well. In this manual you have everything you need to know to operate this logic probe. So there are a lot of drawings, illustrations and schematics so that you understand how it's working. You have specifications, like everything you have to know: voltages, frequencies, maximum current, etc. Then here you have the manual itself that explains all the modes and all the functions of the probe with some drawings and illustrations. So it's pretty complete compared to today. When you get a manual today, it just says how to plug a USB port into a USB plug, a USB plug into a USB port. And then you have a warranty that is just telling you what you don't have to do with your device. So pretty good manual, fits inside box, very good. Then here you have the logic probe. As you can see, it's this yellow-orange plastic case. On the front there are the LEDs, the switches, and here you have a speaker or a beeper. Then here you have the probing tip. There's a plug on the side, and on the back you have the sticker with the serial number and 3 screws for disassembling very easily this probe. Then here, that's something I've written on, max voltage and alarm voltage, so I don't have to look it up in the manual each time. Then on the back you have this cable that's coming out. Sadly you can't replace it or plug it out, it's just fixed. And then you have 2 crocodile clips here that are here to power the device. So you have to plug it in onto 0 to 30 volts and onto the ground, and typically it will be 5 or 12 volts and the ground. Then we have 2 more cables here, one with the crocodile clip here, and one with the, how I like to say, probing hook. And those 2 cables can be plugged in here into this plug on the front, and it's just connected to the probing tip so that you can probe hands-free. So let's see how it works. I'll put the box on the side, and I'll take this circuit I've made a few years ago. So this is a very simple circuit. You have a 555 timer here that is making a frequency that is pretty low in this case. Then here you have a clock. It's the HEF 4017BP that is just taking the signal from the 555 and then just switching the pins on high when he gets a signal from the 555 timer. And then here you have just an amplifier circuit, so it's just a transistor array that is the ULN5, I can't read, what is it? ULN2803A, and this one is just amplifying the signal from the clock so that you can power the LEDs. There's a potentiometer here with which you can vary the frequency and so the speed of the LEDs. Now, how you have to use the logic probe: just take your crocodile clips and you clip one onto 5 volts here and one onto ground here. Here it's easy because I've made access to these 2 points easy, but maybe on your PCBs you have to search a little bit for your ground and 5 volts. The important thing is that the ground and the 5 volts have to be the same that are powering the chips, so that you have a reference here on which the logic probe can then find if it's high or low. As you can see, it's powered now. The open LED is on, saying that you're not touching anything, and yeah, as you can see, when I'm touching it, it's actually going on low because I'm touching the ground with my feet. But it's not the same ground, so it's special. The way you're supposed to use it is just take the probe like so and just touch a leg. This one is connected to the last LED, so let's touch it. And now you can see that it's switching on high when the LED is on, and that the rest of the time it's staying on low. The open or bad contact LED is flashing on the transitions because it's not clear if it's high or low, so it says that it's a bad contact, but it's not actually. Then here you have the pulse LED that is just indicating a change. When it's going from low to high, it's pulsing. You have actually a second mode that is memory mode, so it stays on once it has pulsed one, and so when you have to look out for a pulse, for a change, and you don't want to miss it, then you put it on memory mode, and so it stays on when it has pulsed. And to reset it, you just put it back on pulse mode. Then here you can switch between CMOS and TTL, and this will just vary how it's detecting and how it's making the difference between high and low. As said, there's a speaker here that is beeping when you're going over 30 volts, so it's indicating when your voltage is getting dangerously high, and this is just because logic electronics are mostly on 5 volts, so it's on pretty low voltages. Then here we can take the probing clip and just plug it in, and then you're just supposed to hook it up to your circuit without shorting everything, and now you can see that it's working hands-free like before. So yeah, that concludes this review or this video about this logic probe from Sansei Electronics, so Japanese logic probe. This is a very good device, and as you can see, it's still working fine. So old but good is the right title for this video, and I like to use it. It's much better than modern logic probes that are made, I don't know where, China, and still works fine, good quality, and it has it survived until today, so it will work, I hope, some years more. Yeah, so this was TB Tech for Old But Good Tech. This concludes this episode about the logic probe. Put a thumbs up on this video if you liked it. Don't hesitate to comment the video, subscribe to the channel if you want to see more old but good tech, and I'll see you next time.